I'm going to just go through just a couple of the sort of big ideas that people often get kind of confused with in analytical geometry, and then we'll just go tackle some problems. And I think I found some nice problems for us to look at. If at any stage you're not sure, it's not making sense, whatever, just interrupt me, okay? But otherwise, I'll just kind of go full steam ahead. All right. So basically, the first thing is just this idea of angle of inclination, right? And just an important thing to start off with is angle of inclination is how much a line is sloping upwards from the horizontal, from the positive x-axis. You might, if you're a geographer, you might say, well, kind of this is east, all right? Or if you're not a geographer, you might say it's like 3 o'clock on the clock face, okay? But always that way and always kind of anti-clockwise. Now, what I wanted to show you here is that, in fact, the angle of inclination, it gets bigger and bigger and bigger, okay? But in fact, it can never get bigger than 180 degrees. Once we go past 180 degrees, it starts going uphill again, okay? So a really important idea when we're trying to find an angle of inclination, and remember we've got this formula m equals tan theta, is that theta can only be in quadrant 1 or 2. Those are the only places we're looking for solutions. Right. Yesterday we solved some trig equations. Look at this example over here. All right. This line is going uphill, so it's got a positive gradient. Okay. Our angle of inclination will be acute. Okay. And the reason I say that is because remember what I've just said. Our angle of inclination is only possible to be in this quadrant or that quadrant. I always like to draw in a horizontal line, and it doesn't matter where we put the horizontal line. I think you can see our angle of inclination is in here, and if I move it, that angle's not changing. It's in here where the little crosshair is. It's in here. Okay. All right. What's the gradient of this particular line? Well, I like to just look at what's happened to the y divided by what's happened to the x. In other words, we've risen 2 and we've run across 5. Okay. So it's actually got a gradient of 2 over 5. A gradient of 2 over 5 in sort of simplest form is, sorry, 2 over 5. That is in simplest form. But if we show the gradient, this is actually showing it as 0,4. 0,4 over 1. In other words, 4 over 10, 2 over 5, same gradient. Okay. Now, obviously, if I want you to find the angle of inclination, I would just pull up my calculator. Okay, now we just go shift tan of 2 over 5. Okay, and we get about 21.8 degrees. Okay, and I can ask the computer to show the angle of inclination, and there it's 21.8 degrees. Okay, it gets slightly more interesting and more fun when we've got something like that, okay? Because now we've got our angle of inclination is going to be obtuse, okay? So we're looking for an angle in the second quadrant. I'll put in the horizontal line again. Okay, so our angles that are going to be in here. It's going to be an obtuse angle. Right, the gradient of this particular line, we're dropping down 4, so we have a negative gradient, or we're running across 3. So it's actually a gradient of negative 4 over 3. Okay, negative 1,3. Negative 4 over 3. So what we now know, we know that we're just going to solve a little trig equation where we're saying the tan of theta negative 4 over 3. Now, if you watched the recording of yesterday's session, when I solve trig equations, I don't actually like to put the negative into the calculator. I find what's called a key angle. That's meant to be a key. It looks like a person staggering along. But anyway, undo tan of 4 over 3. Okay, and when we do that, all right, so shift tan of 4 divided by 3, we get 53.1 degrees. Okay, 53.1 degrees. That is clearly not the answer. That is the amount by which I want to be in a quadrant where tan is going to be negative. And although tan is also negative in the fourth quadrant, we're not interested in that. We're just interested in this angle. So the way I'm going to get my actual answer is going to be 180 minus 53.1. And that's going to be 126.9 degrees. I hope, if my maths is correct. Let's just show the angle of inclination here. Okay, 126.87. Yeah. All right. So that's all I'm going to sort of say about sort of some teaching stuff. but we're going to now tackle some questions, and I've chosen them quite carefully that we're going to test a whole lot of skills here. Okay. So this thing, one of the things that complicates this topic for some people is that they don't bother to learn the properties of different shapes. Okay. This thing is a rhombus. Okay. A rhombus is actually a special type of parallelogram. So what it means, it's got all four sides equal, right? And it's also got opposite sides parallel. So it's actually like a square that's sort of been hit by a bus. It's been sort of kicked over slightly. Right. Okay. Because it's a parallelogram, it has all the properties of a parallelogram. Okay. And I'm just going to remind you of what those are. Okay. So not the definitions, but the actual properties of a parallelogram. So the diagonals bisect one another. The opposite angles are equal. The opposite sides are also equal. So that those three properties are properties of all parallelograms. Okay. Now this is a special parallelogram called a rhombus, where the sides, not only are the opposite sides equal, but the sides next to one another are equal. There are now two additional properties, okay, which only apply to rhombuses, okay, and squares, which are also a special type of rhombus. But anyway, okay, the one is that the diagonals are perpendicular. So not only do they bisect one another, but they're actually perpendicular. So they bisect at 90 degrees. And then the last thing is that the diagonals bisect the angles. Okay, so if we know all this stuff about this particular shape in front of us, this whole question is going to be a whole lot easier. Okay, the first question just asks us to find point C. All right, and the easiest way to find point C is there's a couple of ways you can do it. There's complicated ways and there's simple ways. By far, the easiest way to find the missing corner on a parallelogram is to see what happens when you go down the one side in a certain direction. And the exact same thing must happen when you go down the opposite side in the same direction. For those of you that do science, I've drawn what we call a vector here, okay? But basically, when we move from B to A, our X value decreases by 6 and our Y value increases by 8. So exactly the same thing must happen, all right, when we move from D to C. So our X value must decrease by 6. Okay, so it'll go to minus 10. And our Y value must increase by 8. Okay, so there's the coordinates of C. No mess, no fuss. Okay, I'm going to show you that it's quite a nice idea here, is that we can actually confirm that answer by doing exactly the same thing, but using the other parallel lines. Okay, so in other words, instead of going there, we could say, well, when we move from here to here, from B to D, my X value decreases by 6. Okay. No, it doesn't. So it decreases by 10 from 6 to minus 4. So my X value here must decrease by 10 from -4 to -6. And when I go from B to D along here, my Y value stays exactly the same. So when I go from A to C, my Y value must stay exactly the same. Okay. All right. So we've got point C. And the way we found point C would apply to any parallelogram. Okay. Not just to a rhombus. Then it says find point E, giving a reason. Okay. And because this is a parallelogram, okay, a special type of parallelogram called a rhombus, we know that the diagonals bisect one another. So we can find E by just finding the midpoint of either BC midpoint, all right, or we can find the midpoint of AD. And if you had time in an exam, you might want to just kind of check that you get the same answer. But remember how we find a midpoint, okay? different people do it differently. I actually like to just sort of say, well, in fact, it probably, guys, and this is an exam technique thing, it probably makes more sense to find the midpoint of this line where we're not using something that we've calculated. So in other words, I'm going to use AD, all right? Because obviously if I've got C wrong, you get the marks anyway because it'd be a consistent accuracy. But okay, we're going from -4 up to 0. So that's a change of 4. So we must halve 4, that's 2. We either add 2 to -4 to get -2, or we subtract it from 0 to get -2. Our y value is going up from 0 to 8. Halfway would be 4. Okay, most of you are probably using the formula where you just average your x's and average your y's. Okay, we do need to give a reason, and this is just diagonals bisect. Diagonals of a rhombus bisect. You can say diagonals of a parallelogram as well, because it is a parallelogram. It's a special type of parallelogram. Okay, then it says find the size of alpha. Now, this is interesting, okay? Because really, there are a couple of ways, okay? I would say that the most complicated way of finding it would be to work out the lengths, because remember, we now know what C is. C is -10, 8. We could work out the lengths of all 3 sides of triangle ABC, and we could use the cos rule, okay? That's not what I would recommend, okay? What we know here, because we know that the diagonals of a parallelogram bisect the angles, we know, in fact, that angle equals that angle, all right? We also know that these 2 angles are exactly the same size, okay? Because remember, the opposite angles are equal, but also the diagonals bisect the angles. So all 4 of these ones with little blue dots are equal. Because it's a rhombus, we actually know that this is a 90-degree angle. Okay, so if I can work out this angle here, then I can work out B1, and B1 is actually going to be equal to alpha because they are alternate angles on parallel lines. Okay, so let's write all that down. To work out the size of this angle, which I'm going to call D1, okay, I'm just going to use the fact that this line here happens to be horizontal, which is really nice. So basically just the angle of inclination of AD, and it's rising 8 and running across 4. So AD is actually going to be the tan of D1 is going to be 2. The tan of D1 will be 2. All right. So D1, we're just going to shift tan. This is going to be undo tan of 2, which is 63.4 degrees. All right. Angle E, or let's just call this E1 just to save us. And guys, you're welcome to do that on an exam. You can add in letters on a diagram if they're not there. E1 is 90 degrees. Diagonals of rhombus. You can just say diagonals of rhombus. Okay, so therefore B1 is 26.6 degrees. Okay, and that's because of angles of triangle. So I'll just go back there. We've just added up the angles of this triangle here. All right, and then alpha will be equal to B1. Alpha will be exactly the same. Alpha will be B1, which is 26.6 degrees. And that's alternate angles. And remember, if we talk about alternate angles, we must always mention which parallel lines we're using. So it's AC parallel to BD. Okay, BD. Right. Notice that there's often some overlap between Euclidean geometry and analytical geometry, and we are expected to give reasons. Okay. So we've done that. Then it says find the equation of the line passing through A and D. That's just the equation of this line. That's a very basic skill. To find the equation of a line, we just need its gradient, which we've already worked out, and a point. Okay. And we've actually got the point 0.8. Okay. And 0.8, if you wide awake, you'll realize is actually a y coordinate, a y-intercept. Okay. So in fact, the equation of this line is going to be y equals 2x plus 8. But we'll go through it a bit more slowly. Most of you are probably using y equals mx plus c. So we work out the gradient to 2. So we know that y equals 2x plus c. And then we put in a point, okay? And as I said, if you're wide awake, you'll use that point, but let's not use that point. Let's use -4, 0. So in other words, 0 equals 2 lots of -4 plus c. So in fact, 8 minus -8 plus c is 0. If we add 8 to both sides, we get c equals 8. And our final answer is y equals 2x plus 8. Okay, then they ask us to find the area of this rhombus. Okay, all right. And the area is if we have a look at what's happening here, these angles with little okay, so we've got these angles with little blue dots on. We know that they are equal. So are these ones with red dots. Okay, and in fact, what we've got here, because it's a parallelogram, the diagonals bisect one another. So I'm going to put 3 little lines on there and 3 little lines on there. Okay, and this diagonal bisects as well. So I'm going to put 2 little lines on there and 2 little lines on there. Now, if you look at the 4 triangles in this diagram, they are all identical. They are congruent. Okay, we've actually got side, side, side in all of them. All right, we've also got right angle, hypotenuse side, but the 4 triangles are congruent. So all we need to do is we need to work out the area of one of these triangles and then multiply it by 4. All right, so I'm just going to do this last question up here. So the area of the rhombus will be 4 times the area of any one of these triangles, okay? I'm actually going to go with triangle BED. Okay, and so now all we got to do is work out the area of triangle BED, and remember the area of a triangle is half the base times the perpendicular height. All right. I was hoping I had a nice easy answer for the perpendicular height here. I actually don't. So I'm just going to go with half DE times EB. Okay, DE, that length, remember our distance formula, we're just going to subtract. So we know point E is -2, 4. All right. So DE, the sort of distance that the X is changed by is 2. So it's going to be 2 squared. And the Y is changed by 4. So 2 squared plus 4 squared. And then EB, 8 squared and 4 squared. So it's going to be times by 8 squared plus 4 squared. So this is losing its shape quite badly in terms of my layout, but all right. I don't think I'm going to actually calculate that answer. I've sort of run out of space, but hopefully we've got the idea. Okay, right. So this now is a new question, right? And it's about circles, okay? And the first thing it says, give the equation of the circle. Well, to find the equation of the circle, we need to know its center, which we do, and we need to know its radius, okay? So again, we're going to need to use our distance formula. The radius is just going to be mn. It's going to be the square root of, I'll do it more slowly here, our distance formula. It's going to be the square root of 2 x values subtracted. It doesn't matter which way we subtract them. In other words, it doesn't matter whether we go 7 minus 3 or 3 minus 7, because we're going to square the result. And 2 y values subtracted. Just be careful here, because this becomes -2 minus -5. So it's actually -2 plus 5. Okay. All right. And this comes to 3 squared. This comes to 4 squared. We get 9 and 16. We actually get the square root of 25. We actually get 5 as our radius. If 5 is our radius, then this circle has a center of 3, -5. So remember, it's x minus the x coordinate of the center plus y plus the y coordinate of the center. And that equals the radius squared. So just be careful, that must be 25. All right, then they ask us to find point P. NP is a diameter, so it's just kind of on the opposite side, okay? you could let point P be XY, and you could set up an equation using your midpoint formula. In other words, x plus 7 over 2 must be 3, and y plus minus 2 over 2 must be minus 5. I actually think it's easier just to say, what happened to my x value when I went from there to there? It decreased by 4. It must decrease by another 4. What happened to my y value when I went from minus 2 to minus 5? It decreased by 3. It must decrease by another 3. Okay, all right. It doesn't matter if you can't do it like that, but I think visually it makes quite a lot of sense. So it's just going to do exactly the same thing again. Next up, they ask us for the equation of the tangent to the circle. So they're actually looking for the equation of this line over here. All right, this blue line. Okay, and what we know from our, again, it's a Euclidean geometry idea. We know that there's a right angle in here. Okay, so and we need to give this reason. I know there was some debate about it in the trial exam, but guys, the gradient of mn, right? This thing is rising 3 and running across 4. Okay, so therefore the gradient of the tangent, we're going to flick that over and change its sign. It's going to be negative 4 over 3. And we're going to give a reason here. A radius is perpendicular to a tangent. Okay. All right. So now we know the gradient, and we're just going to put it into either y equals mx plus c. I'm actually going to go with y minus the y value. So it actually becomes y plus 2 is the gradient. I'm using the other formula. X minus the x-intercept, x minus the x-coordinate of the point. Okay, this all comes to, in fact, negative 4 over 3x. We've got plus 28 over 3 minus 2. 2 is 6 over 3. So we actually end up with plus 22 over 3. And that's our equation of our tangent. Okay, now, this is interesting because it says find the values of k for which the line y equals negative 4/3 of x plus k will be a secant. Okay, and in case you don't know what a secant is, the question's told us that it'll be a secant. A secant cuts the circle as opposed to a tangent which touches the circle. So if we picture this blue line, okay, and if you're awake, you'll see that we've got the same gradient here. What is plus k going to do to this? And you might say, oh, that's paper one. Yeah, everything's connected to everything else. It's going to move this line up or down. Okay. And hopefully you can see that if the k value is a little bit lower, now we've got a secant. Okay. And we've still got a secant. And we've still got a secant. And we've still got a secant. Over here, we've got a tangent. Okay, and after that, we won't have anything, neither a secant nor a tangent. Okay, so what might be quite a cool idea is to work out what's the equation of that tangent, all right? It's going to be very, very similar. Okay, so the equation of the tangent at P will just be, it's going to have the same gradient, and it's going to go through, remember we worked out that P was minus 1, minus 8. So it's going to be y plus 8, if we go y minus a y value, equals the gradient x plus x minus minus 1, x plus 1. This actually simplifies to negative 4/3 x minus, sorry, there shouldn't be an x here, negative 4/3 x minus 4/3 minus another 8. Now, 8 is actually 24/3. So it's actually minus 28/3. All right. That's the equation of that tangent. So this one with the y-intercept of that just touches the circle. This one with the y-intercept of that just touches the circle on the other side. So in fact, if k is between 22 over 3, less than 22 over 3, and bigger than minus 28 over 3, then we're going to, in fact, get a secant. Here's the k value, all right? And when the k value gets to, that's actually 22 over 3. So that's not a secant yet. As soon as the K value gets to less than 22/3, it's a secant. All right. And when the K value gets to -9 1/3, it ceases to be a secant. So as long as we're bigger than -9/3, -9/3 being the -28/3 that we've got. Okay. All right. So the next question looks like this. Okay. And as soon as I see this question, I'm thinking, oh, that looks like angles in the same segment, okay? And the question's asking us, I'll just zoom in a bit because I've made the numbers quite small. The question's just asking us to find this angle over here, theta. All right. Now, we don't know point D, so we can't really use angle of inclination over here, but we do know that this is also going to be equal to theta. So if I can find this angle, then I'll be home and dry. And my advice with, or my strategy with finding angles using angle of inclination is always to put in a horizontal line. So I'm going to pop a horizontal line in there. Okay. All right. And so question is, can I work out that angle? In other words, this angle in here, alpha, using a gradient? Yes, I can. And can I work out this angle in here using a gradient? Yes, I can. And then I can just subtract those two angles to get the size of theta, and it's going to be the same as that theta. Okay, so let's do all of that. Okay, alpha is actually really straightforward. This gradient, we're rising 8, and we are running across 5. Okay, so the tan of alpha is 8/5. All right, so I can get alpha. Let's just go shift tan 8/5. And we get 58 degrees, almost exactly 58 degrees, okay? I'm going to say now that the tan of beta, let's do this with a green pen, just consistent with the way I've written on there. This is dropping 7 and running across 3. So it's -7/3. And again, I'm now thinking trig equations and I'm wanting an angle in there in the second quadrant. So first thing I'm going to do is I'm going to get my key angle. All right, and the key, I'm just going to undo tan of 7/3. So I'm going to go shift tan 7/3. All right, and then beta itself is going to be 180 minus that value. All right, just to save a little bit of time, I'm just going to go shift tan of 7/3. I get that answer, and I'm going to go 180 minus that answer. So I'm going to go 180 minus that answer, and that's to get into quadrant 2 with that angle. And I get 113,2, 113,2 degrees. So therefore theta, or not theta, I'm actually going to call this A1, okay? Therefore A1 is going to be equal to 113,2 minus 58 degrees. Okay, just a little trick. It's much easier to actually add back onto 50, onto 58. So 2 degrees to get to 60, 40 degrees to get to 100. So we've got 42 degrees and then another 13,2. So 55,2 degrees. And therefore theta equals 55,2 degrees. And let's give a reason for that. And that will be angles, same seg. Okay, right. The next one is quite a cool question. It actually came out of a government exam that I did, was working through the other day. And basically it says this point B can slide up and down on the line y equals x, okay? And it says, where should it be so that if we draw a tangent to the circle from that point, the tangent is as short as possible? I mean, obviously, if it was down here, we can see the tangents. Sometimes this thing just decides to do its own. Okay, it's not going to let me. It's not going to let me put that point where I want it. Okay, that's just, yeah, it's just irritating. Okay, but anyway, it is what it is. Okay, yeah. Okay, so that's obviously quite long. It's clearly going to need to be a whole lot closer here. All right. This is definitely a level 4 problem solving question. Okay. It says find the coordinates of B. Okay. Now, what it tells us is that B lies on the line y equals x. So if we give an x value for this point, in fact, its y value is also x. And that's a really important idea. Okay. That's almost more of a paper 1 idea, but it is definitely an idea nonetheless. We know that the radius of this circle is 5. So in other words, that would be 5. Okay. Can we work out the length of AB? And guys, not AB. Let's say that the center is O, right? Can we work out the length of OB in terms of X? Yes, we can, all right? And therefore, we can work out the length of AB. This, believe it or not, is an optimization question, okay? Because we want to minimize this blue length. So we need an expression for the length, the blue length, okay? And if we think about it, AB squared is going to be OB squared minus the radius squared, minus OA squared. Okay? So AB squared is actually going to be, now OB squared is just going to be the difference between the x values. That's going to be x minus 3 all squared. Okay? And then the difference between the y values, x minus 5. So x plus 5 all squared. Okay, and then minus OA squared. And remember, OA squared is actually just a radius. So this is going to be minus 25. So what we've now got, we've got that AB is actually going to be, it's going to be the square root of, I'm now putting the square root sign in, of all this stuff inside here. And just to save a little bit of time, I'm going to do this quite quickly. We get an x squared. We get a minus 6x here and a plus 10x here. So we actually get plus 4x. We get a 9 here and a 25 here and the minus 25. So we actually get 9. Okay. And now the question we are asking is how do we make this as small as possible? Well, we can work out how to make this as small as possible, either by completing the square, all right, or even by differentiating it, okay? You guys have got your fancy Casio calculator. If you put it in, it will actually tell you the minimum value of this, all right? But just to show you, if we just said, let's just let this thing here be L squared. So L squared is 2x squared plus 4x plus 9. If I want to find out where something's at a minimum or a maximum, I differentiate it. So I'm going to go the derivative of L squared with respect to x, and I get 4x plus 4. And I want that gradient to be 0. And so in fact, x must be minus 1, right? And that's not the minimum length, okay? When x is minus 1, when you put minus 1 in here, you actually get that AB is equal to the square root of 7, all right? The question actually asks, find the coordinates of B. And obviously, if x is minus 1, then the y, remember, B lies on the line y equals x. So B is actually the point, -1, -1. Okay, that's tricky, but what it does do, which is quite common, it allows us, what we've done here is we've worked out the equation, the length of a tangent, okay, using the fact that the radius is perpendicular to the tangent and using Pythagoras. Okay, all right, we don't know point A. All right, just to show you the actual best answer here is at -1, -1, and with a length of root 2.65. So notice here, when this point moves down here, that length of that tangent's getting shorter and shorter. When B gets to -1, I'll get to about 2.65. Okay, that's still getting shorter, B is getting to -1. Okay, my hand's probably not steady enough. Oh, there we go. All right, and there's the minimum length. After that, it starts to get longer again. Okay. All right, and then I think it's the last question. Yeah, it is the last question that we're going to look at. It says, find a possible value of P if this circle has an area of 16 pi units squared. Okay, so this is an unusual question. I made it up, quite pleased with it. All right. So what's the area of a circle? It's pi r squared, isn't it? So area is pi r squared. So for the area to be 16 pi, we actually need r squared must be 16, which means that the radius must be 4. Okay, the radius can't be -4. Normally when we square it, we'd have a plus or a minus. So we need the radius to be 4. Now, the big idea here, and it's the first time we're doing this, I've tried not to repeat any of the skills, is writing a circle into standard form so we know what its center is and what its radius. Okay, and remember, when we put something in here, it's going to multiply with that x and then double. So in other words, to get a -8x, I mustn't put a -8 in here, I must put a -4, right? And likewise with the y's, I'm going to go y. Now this is a little bit tricky because we've got p lots of y's, so in fact we must have half of p. On the right-hand side, we always had a p, but what we've added in now, which is kind of problematic, we've added in 16 here and p squared over 4. What we've actually done is we've taken this equation, which was nicely balanced, all right, and we've stuffed it up. We've actually added stuff in on the left-hand side, and it's not balanced anymore. But we can fix that by adding in the 16 here and the p squared over 4 here. All right, now we know the center of the circle, but that wasn't really important. What we do know is we know that all of this stuff is our radius squared. So in other words, what we now know is that p plus 16 plus p squared over 4 must be 16, okay? And if we multiply everything through by 16, we get we don't need to multiply by 16, let's multiply by 4. Well, okay, in fact, most obvious thing to do first probably is to actually observe that there's a 16 on both sides. So let's get rid of those. Okay, now we're going to multiply both sides by 4, and we get 4p plus p squared equals 0. Don't divide by p, because it's possible maybe that p could be equal to 0. And so if we go 4 plus p equals 0, we actually see that there are two possible answers, p equals 0 or -4. And both of those answers are okay. All right. And what I did is I drew a little sketch. Okay. And so what I've got here is my p-value. And what it's telling me is the area of the circle as I change the p-value. And so notice the circle is getting smaller. When p equals 0, all right, our area is 16 pi units squared. And I'm going to go to p equals -4. You'll see that we also get 16 pi units squared. So it's quite cool that the circle kind of gets bigger. And it gets bigger there, okay? And there's two values at -4 and at 0 where it has the right size. Okay,